Hey, what's going on, guys? Komakigins here. In this video I'd like to introduce the project I'm currently working on, and this is a chessboard widget that knows rules of chess. It's the very early development stage at the moment, and really needs tons of work to bring it to production. But anyway, I've done quite a lot of stuff already, and that's the reason why I wanted to share this sort of a project with you guys. Probably someone might get interested in it. So without further ado, let's actually start. So you can either drag the pieces. Unfortunately, the drag and drop is quite pretty poor at the moment, because in order to make it like in a real chessboard libraries, one needs kind of implement his own drag and drop logic to override this default browser's behavior, and I didn't yet do that, but I was looking for a code how that could have been done, but that's a little bit too complicated for me at the moment. So I hope one day I will implement that as well. So also you can you can move the piece if it's not your site to move. Also you can move the piece where it shouldn't go. You can also click on the source and target square in order to make a move, so this might be useful for tab devices. I've seen a library called Chessboard.js, which is really nice from the GUI perspective, but unfortunately it doesn't really allow you to natively deal with the tab devices, and one needs to use some dirty hacks to make it actually work on a smartphone, which I did for my online version of my BBC Chess Engine. So this is kind of it. At the moment, the only promotion possible is to Queen. I will later add the feature of promoting to the piece of user's choice, obviously. So that's gonna the same for white and for black pieces. And again, like, really lots of ideas in my head at the moment, but when it comes to implementation, it comes much more complicated than you could have think this is kind of possible. So this was the easy part from the user's perspective. And now let's, if you're interested obviously, let's dive into the code behind it. So the source code at this moment is 100% original source code. It has really more features regarding debugging and pre-printing sensible information in the console rather than GUI itself at the moment. So let me actually start demonstrating this stuff. So if you just go to the source code, so there are two files. So here I have test.html, which literally creates the div with the ID named Chessboard, and I'm importing the only script called chessboard.js, and this is the entire source code for the library you've just seen. So it consists of two parts. Well, before we walk into the code, I would like to emphasize the encapsulation technique I've used here that I saw in a chess library called chess.js, which is quite pretty popular. So I'm just creating a board. I'm just creating a variable and assign a function to it. And the entire engine to generate moves and to validate them, and the GUI interaction stuff, it lives within this function scope. So up, down, right over, and here's really quite pretty lot of code already. And when we want to instantiate this kind of chessboard, we just create a variable and creating using this new keyword to create a new object. And this object has a public API that really kind of not that great at the moment. So at the moment it allows only to parse FEN, generate moves, make move. This is the GUI make move, not the internal one. And also a very basic handling for drag and drop, which most likely, well, probably I will rewrite this. It depends on what would be the best way to provide the reasonable drag and drop like in the real world libraries, because what we have now is more like a proof of concept implementation rather than something close to the production. And also we can call whatever method is available within the public API, we can call it. Well, I could have actually shown how this parse fen works. Well, let's probably let's first walk through the test. That is something that I'm sure that would be working nicely, because this is already the third attempt to record this video, because every time I was starting the recording something was broken and I needed to fix that. So let's have a look at the tests here. So here within the test I'm initializing the board position from the fen string. So let's try to pick up somewhat a different fen. If I didn't okay. Okay, oh, I have another one here, thankfully. Okay, so we can specify a different fen, and as soon as we update the board, the board is being initialized from the fen that we have given. It doesn't yet support the validation, so if you pass the malformed fen, it will return basically the undefined behavior, which is not really that great, but I will cover that a little bit later on. It's not the first priority at the moment. So let's move further on. So we can here I'm creating the move list and generating moves and printing the moves that are generated, and this is the core functionality in terms of move validation. So let's say we have this sort of a position, right? So how it works, so we have white to move, right? And we have, okay, it's not really the original position, so let me just restore this to somewhat its original state, like this. It should give 48 moves. Yeah, so this position is known as a tricky position among Chess Engine developers, because it allows you to track most of the bugs within the move generator, and generally it's very useful position for debugging. So what we have here, so we have white to move. Here we have the castling rights. So well, we could have actually print the internal board state every time we make a move. Probably I will demonstrate this a little bit later on. So in peasant square, if any available, the 50 rule moves counter. So if no pawn moves or no capture occurs during 50 moves or full moves or 100 half moves, or also known as splice in this case, we could have figure out that this is a draw basically. And again, like I didn't yet implement the threefold and 50 rule move draw repetitions, but I have implemented this hash keys, the 32-bit key generated like we usually do this when we write in chess engines. Unfortunately, it's a little bit tricky to generate unsigned value in JavaScript. I was trying some hacks, but eventually I decided that we can allow ourselves have negative keys as well, because for the matter of the repetition detection, that's kind of enough really. And I also tried to create a search here, like in the real world chess engine. And I was even experimenting with the transposition table, and again, like I used some hacks to convert the negative number, the negative hash key to the positive one, and try to make use of the hash table. But maybe because of that fact, kind of lots of collisions occurred, or maybe due to the fact that these are only the 32-bit numbers, because well, when we create a hash key for a current given position, we would like to use a 64-bit number because it's more safe in terms of collisions in within the transposition table. But here, for repetition detection purposes, this is literally enough actually. So there is no native way of using 64-bit unsigned integers in JavaScript at the moment. They're preparing some sort of a new standard, but at the moment they're not available. And I was trying to keep this library written in pure JavaScript. I didn't really want to use some libraries that actually allow you to use this unsigned 64 integers in JavaScript even today, like to make sure that it would be working in all the browsers. And again, like from one browser to another, all these tiny little details really matter. So I really want to make sure that my library would be working on whatever browser. And that's another reason to consider the pure JavaScript implementation. So no external dependencies. I didn't even use jQuery, which is a little bit of a pain because I'm really used to jQuery, but here I'm making everything in a pure JavaScript. So this is regarding the board position, and for this board we've generated so-called pseudo-legal moves. So these are this is the list of the pseudo-legal moves, but this list, so the problem is when we want to generate truly legal moves, we need to make sure that kin has not been exposed into a capture, or if kin has been exposed into a capture, the move that is being made on the chessboard needs to be some sort of a move that removes the attacker or moves or steps the site or steps kin aside. So that's kind of it. And as far as I have the pseudo-legal move generator, the matter of detecting actually real moves is the matter of the make move function, which I'll demonstrate a little bit later. So each of these moves kind of tried in the position, and if it is really legal, if kin has not been exposed into a check, then we kind of know for sure that we really can make that sort of a move. So I hope that's quite pretty clear. Okay, so let's move further on regarding these tasks that are available at the moment. So my most the most proud of mine is the perf test. To be honest, perf test is slow as hell in JavaScript, and assuming not the fastest move generator in the world I've created, it doesn't really work that light and fast like in C. But anyway, the number of nodes is exactly what we need to have. We can set whatever depth here, well, but depth of say 5 already makes it think for kind of too long there. Depending on how complex, depending on the position complexity, obviously. So the more variations to walk through, the longer it takes. And well, I also had, I just don't even remember, did I have some more? Well, actually, I remember I've created really lots of console loggers here. Yeah, probably things like print all the attack squares. So, but by the way, let me just figure it out if that's possible still, if I didn't break anything. So let's say print attacked squares. Okay. Yeah, it does. So all the squares that are being attacked by whites are marked as this axis. Well, anyway, I really need to pick up all the possible tests available and bring them all together when it comes to production. But for now, just want to demonstrate a few of them basically. So okay, what else did I promise to demonstrate? Well, probably we could have, so let's just comment this kind of out. We could have print the board every time making a move. Okay, so here is the function to actually move the piece on the GUI, within the GUI on the chessboard. So again, like pre-coded promoted piece at the moment, and I'm using global variables for source and user target. Well, they're not global in terms of the document, they're global in terms of this board function where the entire mode generator and the GUI part lies within. So we're just going to word this to a UCI like move. Well, if we print this move, it would always be printing the promoted piece, which is horribly wrong. So I just could have pretend that you didn't see that I've just commented out this line, and if I just say console.log and this move string, in this case whatever move is made on the chessboard would be reflected. Okay, 16, 18. Oh, I'm sorry, so sorry. Are you kidding me? Hold on a sec, what did I do wrong? Come on. Oh, it's not here, so I broke something. Okay, this is it. Okay, so I feel like I broke something. Okay, and yeah, move piece here. So let's have a look. So say I move a piece, and whatever move I'm making is being reflected here. And this sort of a string is passed for validation later on within this is validate. Okay, where is that? Yeah, this one. So now the interesting part. So move might not be legal, it might be pseudo legal, but anyway we make it. But the idea is that make move function would take the move back automatically in case if it's not illegal in terms of exposing king into a check. So this is how it works. Okay, and also if I make some sort of an illegal move, it's been reflected, but you see like nothing happens, because when this kind of move string goes to this move validation, it returns false, hence the move still remains, it's not kind of like, it's not equal to 1. It's, I don't even know what value it has, but yeah, it's a good idea to figure that out one day. Okay, so let's have a look at the make move function for which makes the move on the internal board state. And probably, yeah, it's a good idea to introduce the internal board state before. So here is the move generator from my chess engine Wukong, which I've been covering here in Chess Programming channel within hexadecimal 88 move generator tutorial series. So we have a list of constants for piece encoding, square encodings, coordinates to create this fancy UCI protocol like moves. Not sure how this notation is called, but anyway, so that's how it looks like. Unicode pieces for pre-printing the chess pieces in the console like this. This array handles the promoted pieces when it comes to promotion. This is the board. So we have oh my god, this is the castling rights. It's not the board, it just has the same structure. So castle bits, castling rights to keep track of whether the kings or rooks has moved from their initial squares, and if so, then castling rights being changed. Offsets for pieces to move them. So this is needed within the move generator. This is the board array finally. I've taken this from one of my previous projects that did involve the p-square tables as well. Again, I was experimenting with an engine based on this move generator, but I didn't really like the results, so I've dropped that. But if you're interested, I have some drafts, so they are available within my chess programming repo in the newly created drafts folder. So make sure to check that if you're interested. But I don't really encourage you of doing that. So we have side to move and peasant castling, 50 rule move counter, hash key that would be generated from either from scratch or using the incremental updates within the make move function, and keep track of the king square to quickly optimize the matter of asking whether the current given key has been exposed into a check or not. I have a custom pseudo-random number generator which generates pseudo-random 32-bit numbers, and it does this regardless of the environment because we have a fixed seed here. So this ensures that the hash keys would be the same in whatever browser, which also kind of something that we really want when we create something chess engine like. So here is the code for Zobrist hashing. So we initializing the random keys to XOR our position elements with. Here is the function to generate the hash key from scratch. Then we go to the board methods like print board, self-explanatory. So print the move list. I've been demonstrating that. Reset board is used within the parse fen method that makes sure that all the board variables being set to their initial values before we kind of initialize position from the new fen string. And then we go to the move generator. So encoding moves as integers for just to make it a little bit faster. So everything like it was in my Wukong chess engine. So square attacked to make sure that key has not been exposed into a check. So print square attacked. I've been demonstrating how this function works. So just literally prints all the squares attacked by a given site. Here is the generate move function, which is the most complicated one probably within the entire library. A couple of constants to, well, actually, as far as I've dropped the search that I don't really need these constants anymore. So almost like I just want to remove them because they were used before when I was testing a search driver and the evaluation. So engine-like stuff. So I was using only captures to generate only captures within the question search. But now, as far as we don't have neither search, neither Nigamax search nor question search that I've dropped because again they're performing too poorly. I really like that, so I need to make sure to get rid of this as well. Yeah, I need to put it into my to-do list to not forget that. So here is lots of stuff that should be done within the make move function in order to not only move the piece but also alter the board state, like keep track of impedance square, if any, handle captures, double pawn pushes, castling, pawn promotions, things like that. So also I'm incrementally updating hash key here. So this is much faster compared to generating the hash key from scratch. Again, like all this sort of topics that regard to chess, to programming a chess engine are introduced in two of my playlists. The first one is hexadecimal 88 board hexadecimal 88 board move generator, and the other is bitboard chess engine in C. They all explain what this kind of code does and how in particular it works. So I'm running all of this code in the live mode, well, almost in the live mode, within 95 video series if it comes to bitboard chess engine, and about 30 videos for hexadecimal 88 move generator. Here is the perf test that proves that actually the move generator works properly. So we can entirely rely on it when it comes to the move validation for our chess board, for our GUI. And here is the parse fen, which also needs to validate the fen. It doesn't do that at the moment, but I should add that sort of a feature. Here is the function that is parsing the move string, which is like e2, e4, or like b7, b8 queen, things like that. So this is the move string from like from the USAP protocol when it comes to normal chess engines. So it either returns the move, if it finds a move within. So how it works? This is worth mentioning. So it just creates a move list, then it generates the moves, then it parses from square to square and promoted piece if available from this move string, and then it simply walks through the moves and asks whether the move that user has just made on the chessboard is actually available within the generated moves for this sort of a position. And if it is, then we just return a move. And again, like if this move, this is the pseudo-legal move, so it kind of like it will return the move that would actually leave the king being exposed into a check, but the make move function itself would make sure that this move won't actually be made on a chessboard. So it would have been made, but then it would be taken back. So that's how it works in regards to the particular move generator. And finally, the GUI. So some constants to make chessboard look like this exactly. It's very like, you know, like GUI probably is the most weak part of this library. Yeah, it's quite pretty ironic because this library should be a front-end library, a GUI widget basically, and unfortunately the GUI part is probably the weakest part of the entire source code. But anyway, here we have the core function to draw the board and hook this on click and on drag events. Again, like I'm not sure if I leave this on drag events like this. Maybe I'll need to write to override the standard browser functionality for drag and drop. Not sure about that, but yeah. So don't hate me for using table here. I know like that using divs would be more fancy, but again, like when it comes to divs, you need some additional CSS style shit. And I really want to keep the minimalist approach, and with this table we can really avoid using CSS there, even though it's possible, but I really like this kind of like minimalist approach here. Also, I'm using images that are stored here. It's not shown, okay. I need to call it chessboard instead. So here are the pieces. And the file name matches the piece encoding exactly. So whatever piece code we have in our inner board representation, that's the exact number. That's the exact kind of like piece here. So I hope that's clear. So we just have a look at the source code. We're just using board, whatever is available within the board square, on the board within the current given square. So that's how we extract the piece code from the chessboard, and then we use it as the file name for our GIF file. We just concatenating them together, and eventually we're getting this like pieces. This is the technique I was inspired by when I was studying Toledo Nano Chess, one of the smallest chess programs in the world in JavaScript and in C as well. So it's quite pretty nice one. So here I have simple handlers for drag and drop stuff. So literally all it does is just initializes the source and the target moves, and this prevent default just allows to literally use the drag and drop to use this drag and drop. So it's kind of, well, just don't really want to talk about that too much. It's not the case. Here is the function that allows, I call it tap piece, so it allows to make it easier to use the library on the tablets and smartphones and touch devices. So it keeps track of the so-called click lock state. So you kind of tap on the source square, then tap on the target square, and that's how you're done basically. And both of this method eventually call in move piece method here and here, no matter how you move the piece, whether by two clicks or by drag and drop. Eventually this move piece is called, and here again, like what I was already mentioning. So we just generating the move string using the source and target square, then validating if the move if the pseudo legal move is returned, we're trying to make it, and if it is actually legal, then it's made on board. If it's not legal, it's not made on board, and that's it. That's how we kind of be able to make sure that only legal moves are made on board. So here I have kind of like, it looks like a constructor if it was about the object-oriented approach. And again, like I have too many object-oriented approach at my daily job. That's the reason why I want to, why I'm inventing this weird ways of initializing the objects and avoid using classes at any cost, basically. Yeah, because I just want to, like when it's not about the job, I really want to make the code that makes fun, basically. So that's one of the reasons. So here we have the self-calling function that initializes the random keys and initially generates the hash key for a starting position. So this works to initialize the chessboard if parseFen function wasn't yet called. And that's it, basically. So here we get the tests and the public API, which is very poor at the moment. So it's like the idea is that the vast majority of the functions that we have within the this board object are not available in public. So that's how the encapsulation works. And I'm using only those functions that actually kind of make sense to in order to interact with this chessboard from some sort of a backend. So ideally, I would like to replace the chessboard I have in my BBC Chess Engine in its online version. So this is the fancy chessboard.js that is created by not me, obviously, but I really want to have some sort of a similar behavior to this one. And yeah, just you can move for both sides, by the way. Yeah. So starting with the book moves. Okay. So yeah, I want to replace this one, and I need to hook it to my chess engine that runs on the free remote server as the backend service, using Python chess library to interact with the to interact via the UCI protocol with the engine executable itself. So yeah, things like interacting via FEN string and via PGN strings as well is something that I'm about to implement. And literally, well, FEN is now done. I only need to add a function to generate FEN from a current given position to make it possible so the board returns the current FEN that is available on the chessboard. And also, obviously, I need to implement a move stack. So every time when I'm making a move on a chessboard, this move should so all these moves appear and they should be stored within the inner kind of board stack. So we could have either export the PGN from that, or so we could have imported the PGN, and again, like, so PGN would be populating the move stack as well. And also having this move stack would allow us to slide through the game back and forth, so kind of like making moves and then kind of taking back, so just to walk through the PGN like it's done in a fancy GUI. So these are the bare minimum features that I'm about to implement within this library. And again, like, well, obviously I will need to make this sliding to be kind of much better. So that's another thing to consider. Yeah, by the way, if I just get rid of this test and don't even use whoa, doesn't work like this. This is interesting. Yeah, this is interesting. So well, okay, let's try to parse FEN. I'm just wondering. I did this public API, but I didn't yet test it, to be honest. So let's have a look if we can grab the starting position. Well, I'm a bit confused why it doesn't work. Oh, that's because, hold on a second, it's not because of FEN, it's just because I didn't draw the board and didn't update it. Okay, copy. Yeah, so I need to provide, yeah, it's a good idea to provide public API for the core function that every developer would be using. So I want to draw the board and draw board and function, and doesn't take any arguments. and I call the internal drawBoard function. Okay, and the same I want to for update the board. It's called draw pieces or update the board. Yeah, it's called update board. Okay, so okay, yeah, update board. Yeah, this should be working. So yeah, now I can say, yeah, forget parse fen. Let's just try to say board dot draw board and board draw dot update board, and in theory this should render a chessboard. Whoa, 60, 72. Okay, I forgot a comma. Okay, yeah, and I can play. I can move the pieces. Yeah, also I'll probably need to provide some sort of a debug mode switch, like debug mode on, debug mode off, to print some additional information to the console. So it would be quite pretty handy when this library would become a real one, and when it comes to the real kind of sort of development progress when it comes to connecting this sort of a chessboard with whatever project developer might actually want to connect it to. So that's kind of it. And yeah, I knew the theory for real pass back in the days. What should be played here? T4. Yeah, probably the move order is horribly wrong. Just remember the general plan here. And probably, yeah, I'm out of theory for a long time at the moment. Yeah, so that's kind of it. So one of the possible application for this, as I can see already at the moment, is to create a web page or even a website for chess bloggers to use this widget to analyze the game. So one could connect the chess engine. Well, maybe I will turn my BBC site into this sort of a project and the service. Obviously it would be free. So yeah, that's kind of a good idea to consider in future. But again, like, really lots of things should have been done to make it work properly. So if you have any ideas, guys, on regarding this project, some ideas or suggestions, I know the critics, like, nobody does this with the global variables and all this stuff. I don't say that I don't accept the critics. I just told you already that the reason why I'm doing this, I have too many best practices on my freelance jobs daily, so I really want to have fun when I'm making something for free. So that's the reason why I'm trying to reinvent the wheel from time to time and try to use the concepts outside of the best practices, if we can say so. So the encapsulation is really needed here, but we don't need any polymorphism or inheritance, which are the core features of object-oriented programming. So we literally need only the encapsulation. And as far as JavaScript allows us to instantiate the object without actually having a class, which is absolutely fantastic feature of JavaScript that I really love personally. We can go over this very tricky implementation, but like, I really love this basically. So that's kind of it. Well, okay, guys, so this is it from my side. I hope you love the project. I'm really waiting for your feedback, so please make sure to leave the commentary down below this video. I will give you a link to the current version of the source code. I'm kind of working on this, so that's how it works. So if anyone ever wants to cooperate on this project, you're welcome, basically. So I will leave my email down below this video, so the interaction would be easier. I would really love to collaborate with some sort of a pro on this project, maybe just to learn on my own some kind of new, cool, fancy techniques, because I don't really know how this should be done, but I really have a great attitude to try to learn something new from this. I don't even dare to dream that someone might have some real-world applications for this sort of a project to embed this into your own production. If you need some chessboard widget on your website, so if that is about to occur, that would be incredibly interesting. So I'm open to kind of job offers. I'm a freelancer, and even though chess programming is my hobby, I have a very rich experience on interacting with clients on my regular web scraping jobs. So if you have some interesting ideas of how you can use this piece of code to make money on your site, and that would be great, so let me know as well. So I'm pretty open to offers, for job offers regarding chess programming. That's my current main goal in my life, basically, to trying to obtain a dream job related to chess programming at any point. But I'm just trying to make some sort of a product that would allow me to come closer to that sort of a dream. That's kind of it. Okay, guys, so again, like, thanks for watching. I think I would be posting the progress of this library and how it gets developed through the time. First, initially, for those of you who has been following my channel, you probably remember that I was trying to live code this library in a series, but I've deleted several videos after, because when you're making something for your own self, it's kind of it's one deal, but when you're trying to create a code that other developers are intended to be reusing later on, you really need to think about lots of things. So the main problem, apart from a chess engine here, is that I was changing the concepts during the development progress, and what was in my mind, what I just started, has turned into something completely different that we see now. So my eventual ideas was completely different to what I came up with so far. So that's the reason why I can't create when I can't make those live coding sessions on this topic. Not because I can't live code this, but because it will be kind of like one video we're coding, and another video we're recoding it back and literally changing all the entire source code. So I've been rewriting this stuff really lots of times already. So I don't think it's pretty interesting to watch, like how guys were writing code all the time. And I didn't yet even done any refactoring yet. So that's another kind of thing here. So yeah, and when it comes to a chess engine, when you know what, when you 100% know what the end result should look like, that's the other deal. So that's the reason why I encourage those of you guys who didn't yet check out my chess engine series here on Chess Programming channel. Make sure to check them if you really want to know how chess engine actually works, and if you want to write one on your own. So my tutorials would help you to do that, and that's absolutely for free. Okay, guys, so see you in the next video. Until then, and take care.